This problem got emailed to me, and I thought it was a pretty good one, so I wanted to go over it in some detail. This is asking about a basketball thrown horizontally with an initial speed of 4.2 meters per second. And the straight line drawn from the release point to the landing point makes an angle of 30 degrees with the horizontal. What's the release height? So this is a good example of choosing your coordinate system carefully to make sure you get your answer that you want. Now what I'm going to do is I'm going to pick the origin of my coordinate system to be down here in an xy frame. I'm going to say that it's released from some height y0, and it follows a parabolic motion over here and impacts at some distance x. Now what the problem says, the clue, is that this straight line from here to the point of impact makes an angle of 30 degrees below the horizontal. So it says that this angle here, if this is V0, this is 30 degrees. And because V0 is parallel to the ground, this angle over here is 30 degrees. So that gives us one of our key relationships in the problem, namely that the tangent of this angle, I'm going to call it theta because I love variables. Tangent of theta is equal to y0 divided by x. Next, I know my kinematics equations that are actually going to be a little simpler because I've chosen a good coordinate system here. So first, I know that x is equal to x0, and I've chosen that to be 0, so I'm about to cross that out, plus v0x times time plus 1/2 axt squared. And I'm being pedantic here, but in parabolic motion, this term is 0 because we have ax equals 0. So there's no acceleration from drag or anything like that. I've picked this to be 0 by choice of my coordinate system. So I know that x is equal to v0x times t, and by virtue of what I've picked in the problem, I have that v0 is all in the horizontal direction. So x is v0 times t. And so v0 here is, just for the problem, 4.2 meters per second. Okay, so that gives me my second equation here. May as well start boxing them because they're super useful. 1, 2. I've got one more equation that I can use, and that's my y direction here. So I know that my final height, which is where it hits the ground, is going to be my initial height plus v0 y times the time minus 1/2 gt squared. And that that's totally a minus sign. Let's see if I can make that a little more minus-y. Okay. Now, we get this because we're in free fall, or we're in near the Earth acceleration, so this is 9.81 meters per second squared, and we've picked y to be up, so this sign is negative for it pointing down. I'm going to say that y equals 0 when it hits, and I also know that v0y is equal to 0 because it's a horizontal throw. So given this, we get the expression that 0 is equal to y0 minus 1/2 gt squared. And from there, I can solve this to figure out what y0 is. So y0 is equal to 1/2 gt squared. I've got a final equation here. So right now I have 3 equations that I've boxed, here, here, and over here. And I'm after y0, but I've got these other variables I need to get rid of, namely x, don't know what x is, and I don't know what time is. So I think that the first thing that I'm going to do is use this tangent expression to come up with something for x. So I'm going to say that x is equal to y0 divided by the tangent of my angle. Now I'm going to use this expression to get rid of my time. So I know that time is equal to x over v0 from this expression here. And then from here, I'm going to plug this in for x, and then I'm going to get that time is equal to y naught over v naught tangent theta. Now I have this t, and that's going to go into this t down here, and I'll finally end up with an expression for y naught. So, and the knowns in the problem. So that's 1/2 g times t squared. Now t has a y naught in it too, so we're not going to be quite finished. V naught squared tan squared theta. And then I can solve for y naught. I end up with, I've got to get it on one side of the variable equation by itself, so I end up with 2 v naught squared tangent squared theta. I'm going to divide that now all by g, and that is equal to y naught squared over y, which is equal to y naught. And hey, that's my answer. So I've got y naught is, just to rewrite without terrible writing, 2v naught squared tangent squared theta divided by g. Finally, it's time to plug in some problems. I got some space up here, so I'm going to go way up here and plug in the values that y naught is equal to 2 times 4.2 meters per second quantity squared times the tangent of 30 degrees, and this is squared, all over 9.81 meters per second squared. And if I plug in the values to my calculator, I get the answer is 1.2 meters. And that is what's in the back of the book. So we give ourselves a pat on the back.